In this question, we have three charges, Q1, which is positive, Q2, which is positive, and Q3, which is the negative charge. And that you can see that they are giving us the values of these three charges as well as where it is on the x-axis. So let's say Q1 and Q2 are distance r, which is 0.2 meters apart. So from here to here it is 0.2. And then let's say that between Q1 and Q3 it is 3/4 the value of r. So that's from here to here. Now the question is, what is the net force on Q1? So let's look at this. We have three charges here. So Q1 and Q2 have an electrostatic force, and Q1 and Q3 have an electrostatic force. So let's look at them separately and then see what the net force is. So Q1 and Q2, they are both positive, which means they repel. So since the question is asking what's the net force on Q1, this is what we care about. So what are the forces on Q1? So Q1 and Q2, both positive, which means they repel each other. So at Q1, they repel, so it goes to the left away from Q2, and we name it F12. F, the force on Q1 because of Q2. And likewise, we have Q1 and Q3. Now, Q1 is positive, Q3 is negative, which means they attract each other. So at Q1, the arrow should go to the right towards Q3. So it's that, and that is our force F on 1 because of 3. Now you see that I'm not drawing anything on Q2 or Q3, and that's not because there aren't any forces on Q2 or Q3, and that is just because it's not the question. The question is what is the net force on Q1. So now we have F12 and F13. So let's just try to figure out the magnitude, meaning how big are these values, what's the Newton value of this. So if you remember, F equals K Q1 Q2 over R squared. So Q1, Q2 meaning the first charge, the second charge, and divided by the distance between the said two charges squared. So let's try to find out F12 first. So F12 is K 10 to the 9th. And then I'm not writing the units here. And then we have Q1, which is 1.6 times 10 to the negative 19th coulombs. And then we have Q2, which is 3.2 times 10 to the negative 19th coulombs, divided by the distance between Q1 and Q2, which is R2 meters, or 0.2 meters. So this is 0.2 meters squared. So this should be in meters right here. So this value gives us 1.15 times 10 to the negative 26th newtons. Make sure that these are in coulombs. The charges are in coulombs and the distance is in meters. If it's in kilometers or centimeters or millimeters, most probably, then you have to convert it into meters. Likewise, now let's find out F13. F13 is K times 1 Q1, which is 1.6 times 10 to the negative 19th, and then times we have Q3. Remember, these are absolute values, so even though Q3 is negative, we put in the positive value here, and then divided by r squared. So r between, this is the r between F1 and r between Q1 and Q3. So we see that it is 3/4 of r. So it is 3/4 of the r value, and then the entire thing squared, and that gives us 2.05 times 10 to the negative 26 newtons. So how do we find the net force? So F1 net, and both these forces are on the x-axis. It's not two-dimensional, it's one-dimensional. And if we take positive as the right hand side, then we can find out we have F13, which is positive, and then F12, which is negative. So we have positive 2.05 times 10 to the negative 26 newtons minus F12, which is 1.15 times 10 to the negative 26. Again, the reason I'm having 13 as positive is because it is pointed towards the positive x-axis, and F12 is pointed in the negative x-axis in our diagram, so I put it as negative. So that gives us 0.9 times 10 to the negative 26 newtons. So this is F1 net. And this is the magnitude, meaning how big is this number in newtons. Now vectors are both magnitude and directions, and force is a vector. So what is the direction here? As you can see, this is the positive value, which means F13. So F13, as you can see, is greater in magnitude than F12, meaning the net force is in the direction of positive x direction.